Okay, sure.
So we know when to begin to expect discoveries.
What's the big mission that's reaching its
fruition?
fruition?
Well, no, there are missions in progress now to try to understand dark matter and dark energy.
Okay.
More than we currently do. We know it's there, but it's a complete mystery. We don't understand the origin of 85% of all the gravity of the universe. It's not black holes, comets, stars, planets. It's none of the above.
So the math says there should be more there, but we can't see it.
Right. So it's actually missing gravity rather than missing mass. I mean, sorry, it's gravity with no known source.
Which is what I said. Which is what I said.
I like to think of it as dark gravity. It's
dark gravity.
It's really dark gravity.
Wow.
That's really what it is. Then there's some mysterious pressure in the vacuum of space.
What do you mean?
Which we call dark energy. But we should just call those Fred and Wilma. I joke about this because we don't know what they are.
So wait,
don't give it a name that makes you think we know what it is because we don't actually know what it is. But it's there.
And we know the dark matter is there because it exerts this gravitational pull on the galaxies that we can see.
We measure it. A mysterious pressure in the vacuum of space that is forcing the universe to accelerate in its expansion. We are dumb stupid about what these two things are. All right? Now, normally that's not a problem. Like, until you look at this chart, okay? So everything we know about the universe, what we're made of, galaxies, stars, planets, that's all right here. So, according to this chart, we are 96% stupid in the universe. You're happy about that, apparently. I don't know what that means, you know.
Found that the stars in a galaxy are moving faster than we can explain. The gravity of something that we can't see must be holding those stars in their orbits. The ability is that we may actually produce these dark matter particles. You've all heard of the Large Hadron Collider at CERN, our sister laboratory in Switzerland. They're bashing protons together at very unprecedentedly high energies. And the hope is that perhaps in one of these collisions of protons, they may produce dark matter particles, WIMPs, that we could infer through their signatures in these colliders. And again, to give you a sense of scale, a galaxy 100 million light years away is moving away from us at 2,000 miles per second. So the universe is kind of humming along.
And I've written about this because I lose sleep over this fact. Can I share this? I don't want to be blamed.
I doubt I could stop you.
I don't want to be blamed if you cannot get to sleep tonight.
No, I'll be okay.
Okay, all right. So this dark energy in the future will render the universe so large, having accelerated so significantly that all the galaxies of the night sky will have accelerated beyond our horizon.
What?
And all the galaxies are the source of our knowledge of cosmology, of the Big Bang. Everything we know about the history of the universe comes to us from these galaxies. If they accelerate beyond our horizon, the next generation of cosmic explorers will only have the stars of the Milky Way to think about. And so there would have been an entire chapter of the universe ripped from their view. And they will be trying to contemplate an understanding of the universe without a significant part of what its past was. And so I lose sleep wondering, today, was there some previous chapter ripped from the universe itself? And here we are. And here we are, you know. Let's begin by asserting something that's not strange concept, that stars are in the business of making energy. And to be in the business of making energy, that's all they know how to do. If you look at the sun, the cross-section of the sun, what you see is down in the center, that's the hottest place. It's much, much cooler out to the surface. And it's in the core, that's where all the thermonuclear fusion is going on. The sun is making heavier elements. It's converting hydrogen into helium. But that's not the interesting elements. The interesting ones are the ones that we're made of. So the ones we're made of, who's going to make those? Those are the high-mass stars. As it moves up the periodic table, one of the elements it's going to end up with is iron. time to fuse iron. So it gets to iron, it fuses iron. Not only is it not good for it, because it's not giving up any energy, it's actually absorbing energy. And the whole star destabilizes. And it collapses. It collapses in a matter of hours. And the collapse of that star rebounds from the center in a titanic explosion that is as luminous as 1 billion stars. And we call those objects supernovae.
And this is a gallery of about 500 supernovae that we discovered in the mid-2000s using the Sloan Digital Sky Survey.
The Big Bang, by the way, could fit into a larger story. For example, the multiverse. Big Bang is probably not the whole story. It's probably a piece of a bigger story. So, and watch it show up in news accounts. It may be that the dark matter is not matter at all. It's the gravity from ordinary matter from a nearby other universe in the multiverse, whose gravitational influence we feel. And here we are, saying, ooh, we have a mysterious gravity, call it dark matter. Really, it's just ordinary matter doing its thing in an adjacent universe. So a multiverse can give you some predictive power, but it's really out there right now, and so we need to give it some room to mature.